In this video, what I would like to do is walk through some simple Linux commands that you'll be using a lot as you go through this course, and also do an example of editing and compiling and running a C program under Linux. So I'm using a CentOS 8 virtual machine here. These directions will be similar whether you're using a different distribution of Linux, Mac OS, the Windows Bash subsystem, or Cygwin under Windows. All of those are pretty similar once you get to the point of issuing the commands. Now, how you open up the editor and how you edit the files and get to a terminal window are slightly different, but that should be a relatively straightforward thing. If you have questions, just let me know. So I'm going to open a terminal, and that will dump me into my home directory. So if I do pwd, you'll see that I'm under home/whuber, which is my username. When you launch your terminal, this is where you'll be. This is your home directory. And I can get a list of the files that are there if I say ls, and you can see right now this is a brand new installation, so I just have the default directories. I'd like to make a special directory for this class, so I'll make directory, and I'll call it CSC220, and you can call it whatever you want, it doesn't matter. But I would recommend not putting actual files in your home directory. I would recommend creating at least a separate directory for each class you have. So now if I do an ls, you'll see that I now have the CSC 220. If I do ls-l, and this -l is what's called a flag, you'll see that I get a list of the files, but they also include when they were created. So you can tell that I created this virtual machine 2 days ago because all the default directories were created then. Right now it's May 11th at 6:40 in the evening, and that's when I created this directory. So to get into that directory, I'm going to cd csc 220. And there's nothing there, which is fine. Actually, if I do ls-a, that says list every file in this directory, and you'll see that there's two files, dot and dot dot. And this is the current directory. This is the parent directory. So if I do cd dot dot and do pwd to print my working directory, you'll see I'm back to my home directory, and then I can cd back into CSC220. So no files there yet. So I'm going to create a C file. So now if I do an ls, you can see that hello.c is there. So now I want to edit that file. And there's a couple ways I can do this. Now I like to have multiple windows, one window for editing, one window for issuing commands. And there's a couple different editors you can use. It doesn't really matter as long as it's a text editor that generates ASCII text. So if you're using Linux, I would recommend, if you're just starting out, using something like gedit. Now to type the file name, if I type just H, I can press tab and it'll actually complete the rest of the name of the file. So it's just a real quick way to save a little bit of time typing. And I press enter, and here's my file. So let me type this out real quick. So there's a really basic C program, and I'll save this file. And I'll close it. So now if I do ls-l, you'll notice that I can see that I have 77 bytes of this file, and I wrote it 3 minutes after I created the directory at 1853. So to compile this, I'm going to say GCC hello.c, and I'm going to tell it I want to use the C11 standard, and I want to get all the warnings. So this says -w for warnings all. Give me all the warnings. And I also like to use the pedantic flag so that it's very pedantic about the errors that it gives me. And so I've compiled the file. So now when I do an ls, you'll notice there's a new file here, a.out. So let me do an ls-la. So remember, L gives me a long listing. A gives me all the files, including hidden files. So you'll notice the directories are blue, the executable is green, and the C file is white. And this may vary on your particular machine depending on what your color settings are. But you can get a little bit of information when you do ls-l using those colors. And there's other ways to tell that we'll talk about later in the semester. But for now, that gives you an idea of this is an executable file. So if I type a.out, it says command not found. That seems to be sort of a surprising thing, possibly, because I'm looking at the file. When I do an ls-l, it's there. But when I try to run it, it doesn't work. And the reason is when you give it a command, there's something called the path. That's stored in an environment variable. And to see what an environment variable is, you can write echo and then $, the name of the variable, which in this case is all caps path. This is where it's going to look for programs to run. None of these are the current working directory. Now, I don't want to put that current working directory in the path for security reasons. So what I can do is I can specify look in the current working directory by saying ./a.out, and that prints hello.world. Now, I'm not happy with this because I forgot to put a new line, so I got messy output. Let me do gedit.hello again, and what I'm going to do is I'm doing the up arrow so that I can recall the previous commands that I issued. And that line is ugly. Something messed up there. So let me do Control-C. That cancels what I'm currently doing. I can use the up arrow and down arrow to go through the command history. Again, another thing to save some typing. I'm going to open up gedit. I'm going to resize this window just so that I can see my code and I can see my output. So I need to add a new line here. I'm going to save it. And then if I try to compile, notice I can't actually do anything over here. And the reason is because this terminal is running gedit right now. So if I close gedit, notice I get that prompt back. So there's a couple options here. What I typically do is I'll have multiple terminals open, although that's because I use a different editor that runs in the terminal. But if I want to still use gedit, if I put an ampersand at the end of the command, that tells Linux to run that in the background. So it's going to open a new window, but as far as this particular terminal is concerned, that process is running in the background. So now you'll notice I have that, I can issue commands again. So let's compile it and run it. And notice I didn't have to type anything, I was able just to use up arrow. And it says hello world. One other thing to show you is if you prefer to use VI, I can open a second terminal. If I say VI and then I want to edit hello.c, notice there's nothing there. And the reason is because this new terminal opened up in my home directory. So I need to change to the directory where that file is, which is CSC220. And if I just type CS and then hit tab, notice it'll bring up the rest of it for me. And now I'll say vi hello.c. Notice I get some nice syntax highlighting here. So let's say I want to edit this a little bit. I'll just put a quick comment at the top. I'll save that. And if I do an ls-l, I can see that that file is a little bigger now because of the line I just added. And it was updated today. So this is my new updates. It doesn't change how the code runs at all, but if I want, I can compile it, run it, and I can get the output. So that's just a real quick example. The commands we use with cd, ls, those are the ones you're going to use the most to navigate around the system and to compile and run your code.